Good morning, everyone. Welcome to the webinar, Introduction to Voice Security Certificates, TLS, and Trust, presented by Nick Kwiatkowski from Michigan State University. Just a few housekeeping items that I'd like to go over before we get started. Please make sure to use the chat window to ask questions. You'll find that at the bottom of your GoToWebinar screen. Moderators will be watching the chat, but Nick may not be able to answer at a certain time, so we might push them to the end of the hour. Today's webinar will be recorded and available for on demand by the end of the day, so please be on the lookout for that. And then also, of course, the short evaluation will pop up as you exit the webinar. Please be sure to take a minute to provide your feedback about the session today and what you might like to see going forward. All right, Nick, ready to get started.
Thanks. And also, if any of you would like to follow along with your own PDF copy, I know some people do appreciate having accessible versions of the presentation available. You can grab that from www.msu.edu/tilde/nk/security.pdf. There's also a link in the chat screen as well if you would rather download it there. So, this is an introduction to voice security. We're going to be talking about certificates, TLS, and trust. I am Nick Kwiatkowski. I'm the Unified Communications Manager at Michigan State University. And this topic should also be talking about security and you, why we all day drink. So, Ray talked about housekeeping. We're going to briefly talk about security and voice over IP, security certificates, establishing identity, building trust, and then quickly implementing certificates in your environment, and also some tools of the trade. This session will not necessarily be prescriptive. This is how you implement security. This is not going to be this is how you generate certificate signing requests. This will not be, this is how you do A, B, and C. This is mostly going to be a background knowledge and a primer for you about what are you actually doing when you follow these steps. So just a little level setting when we talk about that here. So a little quick about me. Again, I'm the manager of the Unified Communications team here at Michigan State University. I'm also an adjunct professor within the College of Communication Arts and Sciences here at Michigan State University. I teach telecom, data networking, and network security. And then also involved with Avaya, quite a few different things. I'm a founding member of the Lansing Makers Network and also part of the Apache Foundation, Software Foundation as a member committee and PMC. So security and voice over IP, what you're actually here for. So this topic kind of popped in my mind about a year ago when I was, there was an auditor dealing with PCI DSS going through our office with a clipboard. And the question that they came to my office and they had, like, again, had a little clipboard and they said, is your phone system secure? Now, unfortunately, this is a webinar, so I can't hear you laughing for those of you who should be laughing at this one here. But when, you know, a question like this, like, yeah, of course it's secure. Everything is great. That's, you know, that's pretty much the answer I should have given. Instead, I think I did some sort of diatribe about, oh, you know, you can get a Volvo and, you know, it is totally safe and all that type of stuff unless you're driving like Crazy Taxi or, you know, how I drive with Mario Kart and things like that. So when you say is something secure, you're really talking about, you know, there's 1,000 things you have to deal with. Login security, encryption of, you know, the data and the voice actually in motion. When I say in motion, like actually going across the wire. Encryption of stuff at rest, configuration security, patching, updates, fixes, all that stuff. The physical security, you know, having locks on doors and video cameras and all that type of stuff. And, you know, security practices of end users, you know, are they, you know, just randomly reading credit card numbers over the phone or that type of stuff? Or, you know, security is a huge, huge topic. And to simply say, hey, you know, put a stamp on it, yes, this is secure, is kind of a misnomer. Now, when we are actually going to be talking about security in the context of this presentation, we're actually only talking about one particular topic, and that is the encryption of that voice and data in motion. The rest of the stuff is going to be pretty basic practices, and these are things that, you know, if you get your Security Plus, if you get talk with somebody in your organization who deals with security and all that type of stuff, the rest of these things should already be taken care of. Login security, I mean, you can probably just look at a couple blog entries about, what is login security? Like, how do I, secure my passwords, that type of stuff. So the thing that makes a PBX a little bit different, and probably why your security team is pushing this onto you, is going to be actually making the voice and the data when it's moving between servers actually secure, so people can't listen in on your conversation or read back credit card data, that type of stuff. So implementing the security domain can be one of the more complex portions of voice over IP setup. I'll be honest, we're all voice professionals at this point. We've all probably figured out how to do voice over IP. We know how to do H323 phones. We're starting to figure out SIP, the data networking, QoS, all this other type of stuff. We've got this down now. The part that is now being thrust on us in the last few years is the security piece. That's something particularly people who have been dealing with security for our phone systems for years and years and years just never had to deal with. I remember when I first started installing phone systems, the idea of security, passwords for a phone system and all that type of stuff. Literally, I could go to any customer site, look at the bottom of a keyboard, and in Sharpie, you'd actually have a password written on there. Sometimes if we were lucky, even had the login and password written on the bottom of the keyboard, and that was considered, that's the best way to do it because, security. But security itself is compulsory. Even if you don't care about security, even if I say all I do is talk with my friends over the voice over IP system, I really don't care if somebody can listen into it. It's mandated now. In Avaya's latest versions of software and all that type of stuff, even for demo purposes, you have to deal with this. This is like the basics of getting something set up. In fact, you can't even get things to work right unless you have security turned on. So you should consider a security strategy before you start much else. You do have options. You don't have to, if you don't own the security within your own organization, you probably have to invite the people that you do that do this. You shouldn't have to be worried about. You shouldn't have to be scared about involving security folks, but you do need to make sure you talk to them in the same language, because if you don't, they probably will hoodwink you. They'll probably, make you scared. They'll probably set things up the wrong way because it becomes more secure. And then, we break things by having things way too secure. So security in itself for voice over IP really involves two important parts. One is establishing trust, and the other one is encrypting the conversation. And when I say establishing trust, do you trust who you're talking to, and do they trust you? That's really one of the more important things when we're dealing with the voice over IP security. And that's probably the piece that is least talked about, and probably the thing that you just have to figure out. Once you figure it out, the rest of the stuff kind of falls into place. With anything going over a TCP/IP network, you'll want to encrypt the conversation. In fact, a lot of standards such as PCI DSS mandate it. If you don't know what PCI DSS is, that's the Payment Council Industry Association. Essentially, the people who own Visa, MasterCard, Discover, American Express, that conglomerate comes together and they've written a set of standards. And a piece of it is they're saying you have to encrypt conversations going across your phone system. Otherwise, you start getting things in or out of scope and all that type of stuff. So just one second here. All right. So in Avaya Aura-based systems, the encryption for the data in motion, so again, we're talking about that SIP traffic, media traffic, configuration traffic, all that type of stuff is done with certificate-based encryption. That's other known as public key cryptology, using PKI or public key infrastructure. So there's a lot of different ways of doing security. This is the way that we do things in any type of voice system. And I'll even step back and say this is also how it's done with all voice over IP systems. So your Cisco systems, your Asterisk systems, your Open SERs, all that type of stuff are all using PKI. Once you have your PKI in place, enabling encryption is usually just a matter of enabling the encrypt settings. And every application has it a little bit different. Communication Manager, for example, if you go to your signaling group, you change a signaling group from TCP to TLS. Now it's encrypted. If you want to encrypt the media, you go to the IP codec setting and you say, turn on encryption. It's really I hate to say it's that easy, but it really is that easy once you're at the point that you are that you have your PKI or all your certificate stuff set up. For system manager, session manager is done by defining the TLS protocol when you're defining your entity links. Voicemail, pretty much the same way. You say, I'm using encryption, blah, blah, blah. So, pretty much everything that you're doing, once you have this hard stuff of actually the certificates exchanging and all that type of stuff, it's just a matter of turning on these settings and then it figures out the rest generally. So with all that, let's talk about security certificates. So security certificates, other known as X509 certificates, you will hear some documentation talk about X509 certificates, are essentially they're blobs of text. They're not a specific file type. They're not anything in particular. They're literally a blob of text. And in that blob of text, they do a few things. One is they establish identity. So they assert who you are. They establish trust. So who trusts me and who do I trust? They hold metadata about the certificate itself. So when does it expire? When was it issued? Who issued it? Information about your address information, where is it supposed to live, all that type of stuff, and even information about what is the certificate supposed to be used for. A security certificate is presented for all TLS connections. That'd be connections that utilize SSH, HTTPS, voice over IP encrypted links, all that type of stuff. Those are all using that security certificate, and they're presented every time you make that initial connection. So when I was coming back from Phoenix, it kind of dawned on me, hey, security certificates are really similar to passports. And that analogy, when I started thinking about it, actually started making a lot of sense. So security certificate, very similar to a passport, establishes your identity. In that passport, it actually says, your name, your address, your phone number, well, maybe not phone number, but it says all sorts of, identifying information about you. The passport also says who trusts you that your identity is correct. So my passport, issued by the United States would say, this is Nick Kwiatkowski, and it was, this passport is issued by the United States. So pretty much it says if anybody trusts the United States is able to have this or to generate this passport, they can trust that I am Nick Kwiatkowski. And then you present that passport before you're allowed to talk or enter to the country. So, anytime I do any type of encrypted link, I'm always going to be presenting this, this passport that asserts who I am and a bunch of other information. And then, then if the other person accepts that, so they trust who trusted me, then that conversation can start. All this, certificates are also known as identity certificates, kind of going along the same analogy, or server certificates. So if we now have counted the different ways that people actually identify certificates, we now say they're security certificates, they're X509 certificates, they are identity certificates, or they're server certificates. Those all mean the exact same thing. So what does a certificate actually look like? This blob of text that you're seeing here on the left-hand side is an actual certificate. It's actually, I think, one I pulled down from my own server. So it starts with this thing that says begin certificate and it ends with this thing that says end certificate, and then there's a whole bunch of gobbledygook, in between. That blob of text is essentially can be run through a couple of algebraic equations, and out of that you get a whole bunch of information. And we're going to talk about that, what that information is here in just a moment. Now there are other types of certificates as well. So a security certificate can also be what they call, so this is what's known as in PEM format, PEM. There are other certificate types that are like DER, PC12, PK12, and a bunch of other formats which can be encrypted. They don't look like this. When we're dealing with most security certificates and when we deal with any of this type of stuff, generally, the security certificate is we want to deal with it in PEM format, which looks just like this over here on the left-hand side. So what type of data does that security certificate actually include? It is going to include the dates that the security certificate is valid. So that'd be a start and an end date. It's going to include a server's name, so other known as a common name or a host name. So this would be, let's say, for example, www.iaug.org. It would include the location of the server, which would be the municipality, the locale, country, organization, organizational unit. It has a serial number, and it also says who can vouch that the certificate is valid, so who is the issuer. Security certificates themselves are actually public documents. They are meant to be exchanged and for all the communication paths. I've run into quite a few organizations where they're like, oh my gosh, my security certificate, you can't see that, it's private, it's secure. This is actually for every time that you establish a connection with this organization, they're going to give it to you anyway as a part of that TCP link up when your server is talking to them and they're talking to you. So there's this website called SSL Shopper, and I'm going to refer to them a few times in this presentation. You can actually take any of those security certificates. So let's say like the one that I had on here just a moment ago. Let me go and pull one of those off here again, just so I can show you here. Ooh. Just a moment here, I'm actually pulling one of these certificates down so I can show you. If we go to this link, the sslshopper.com, let me go and pull my browser over here. They've got this thing over here that allows you to decrypt or essentially decode any one of these certificates. I can go paste the certificate in here, and along the bottom, it gives me all the information. Again, the country, the organizational unit, organization, common name, valid to and from, the issuer, serial number. Hey, this is serial number 1. So there's all sorts of information you can get out of these things that comes out of this, essentially the gobbledygook of the certificate. Let's continue on here. So you can quickly see all the information in a certificate by clicking on the lock icon or going to any developer or the developer tools on any website. So if you're using Chrome, you have to go into what they call developer tools. This is in your web browser. If you're using Internet Explorer or using something, Firefox or those, you can usually just click like on the lock icon, and when you click on that, it will show you all sorts of information. An example here is from Chrome, the certificate from Avaya.com. You can see over here it's got a common name, and it tells me some information. Organizations Avaya Incorporated, Basking Ridge, New Jersey, United States. Again, this certificate is presented before any real communication is transmitted between your browser and the server and back and forth. The neat thing with certificates then is once the server presents the certificate back and forth, or they present the certificate to you, your browser then gets to decide if it wants to continue. And this is where a lot of communications fail. So if you're in a web browser, you probably, if you've gone to like System Manager or whatever, you see this thing says, oh my gosh, big warning, I don't know if I trust this particular site. The problem with voice over IP systems is when that link is set up, there's nothing that can pop up a message on your phone saying, hey, do you trust this? It just stops the communication. So chances are if you're having an issue with certificates, things just don't work. So how do we build trust? So trust is built on what's known as the realm of trust or trust chain. Essentially, like I mentioned before, your certificate will be signed by somebody. That certificate that is signed by your certificate may have been signed by somebody else and keeps on going up and up and up. You can have some that might be signed, let's say 15 levels deep. If you trust the uppermost certificate in a chain, then you trust all the certificates that certificate trusts. So think of it like I trust Alex Trebek to know the answers, and he trusts his librarians. So therefore, I trust his librarians to know the answer. Again, it's that the transitive properties that you might have remembered from algebra or your math classes and things like that. When a certificate is signed, the issue puts what they call their thumbprint onto it. So I take a certificate and I say let's say I want to be trusted by Paige over at IAUG. I can give her the certificate, she can go sign it, and now I have this thing, and because she trusts it, and if you trust her, you now trust me. So how does this actually work? So again, if I go to that Avaya.com certificate and I pull it up, I can see over here that this sanscert1.avaya.com, which is what they're presenting for that site, is trusted by GeoTrust RSA-CA 2018, which is trusted by DigiCert. Now, as long as I trust DigiCert, which in this case here, my computer does, I now trust Avaya.com. And this is how we start building these layers of trust. That highest certificate in that chain is known as the CA, or the certificate authority, or a root certificate. If you actually look at the certificate itself, it issued itself or it's self-signed. I'm sure you've heard the term self-signed certificate. Essentially, that says, that's a certificate that says I trust myself, and so you natively have to trust it. But if it is the highest thing in the chain, if you trust it and it trusts itself, and it trusts a bunch of other folks, those other people are also trusted by you because you trust it. See, it's like one big happy family. So most operating systems and devices have a set list of certificate authorities that they already trust. So companies like Network Solutions, GoDaddy, Amazon, Microsoft, your computer, your cell phone, your computer, anything else that you have, natively trust all these companies. And because you trust them, if they sign a certificate, you now trust anything that they've signed. Companies can petition to have their certificate authorities, certificates trusted by browsers. And then certificate authorities need to have a process in place so that only sign certificates for people that they know and they can verify that they own the domains. So for example, I can't go to Network Solutions and say, hey, I own google.com. I clearly don't, Google does. And part of being trusted by the browsers is that you have a process in place that says, Network Solutions can't just sign a certificate from anybody. They only sign certificates that they actually know. And a piece of that might be that it used to be that if you want to get a security certificate from Network Solutions, you actually had to sign in. You had to sign a form saying that you actually were this company. You had to send in letterhead, all this other type of stuff. Nowadays, that's not necessarily the case anymore. You can, as long as you have a credit card, and then you actually have the domain name in your possession, you can usually assert that you own that particular thing. So who do you already trust? So Mozilla actually has a pretty good list of all the companies that are already trusted by your browser, already trusted by your operating system for like Android OS, or the Apple operating system for iOS and all that type of stuff. So if you go to that link over here, you can see a list of all the thousands of certificates that are root certificates that are already trusted by, again, all the operating systems and all stuff. Remember, we mentioned DigiCert is who Avaya used. So it turns out DigiCert is a company that has just a ton of these global certs, these root certificates. Thwart is one of them. VeriSign has some of these over here. Entrust is another one. And if you ever wanted to see what their certificates look like, you can actually pull them down, and all sorts of information like that. So you can pay to have these certificates authorities sign your certs. They usually cost between $10 and $100 for each one of these transactions. Some certificates can actually cost thousands of dollars. Now, there's a couple of additional properties in certificates that essentially have additional levels of trust. So I'm sure you've gone to your bank's website and you noticed that when you go to the HTTPS, your bank's website, that the padlock turns green. It actually says the company's name in the address bar and all this other type of stuff. You can actually pay extra for that. Now, a lot of companies are going to try to, if they sign your certificates, they're going to try to sell you up to those types of authentication mechanisms and all that type of stuff. It's not going to actually win anything when we're talking about phone systems. A phone doesn't care that you paid extra for a certificate. A browser does. A phone does not. So pretty much what I say is find the cheapest certificate that you can find that's trusted by the devices that you're trying to deal with, and away you go. It works all the same way when we're trying to secure our voice systems. So if you don't want to buy your own certificate from an established certificate authority, so you don't want to pay $10 for every single voice for IP phone that you have per year just to have information flowing back and forth, you can actually create your own security certificate authority. You have the ability to create and sign your own security certificates at no cost. You have to run some software to do that. However, you would need to establish trust for each device that needs to talk to the server and present that cert as signed by your CA. So essentially, you need to somehow figure out how to establish trust between the certificate authority and whatever you're using to access your systems. So having a device to establish trust involves taking that certificate authority cert, that root cert as we like to call it, and importing into that device's trust store. So trust store is essentially a list of security authority certificates that a device will trust. Every application and operating system will have its own trust store. So communication manager, messaging, SBC, every phone that you have, all the operating systems that you have, all of them have their own trust store. Some applications are really picky. They want copies of those intermediate certificates as well. Remember a few moments ago we talked about the this realm of trust. Some applications, for example, J series phones and 9611 phones, for example, they want to have copies of every single certificate all the way down that trust chain. And a lot of it is because a phone doesn't have enough intelligence to know where to download those particular security certificates that are intermediate. So they don't know that, they can't establish that entire line of trust. And when you deal with some of those types of applications, again, pretty much anything we're dealing with on the Avaya side, you're going to want to import every single certificate along the way. So it turns out that your copy of System Manager is a certificate authority. And by default, all your session managers already trust it. The problem is nothing else does. So you're going to actually have to do a little bit of work to either break that trust or to implement that trust on all your other devices. So again, the neat thing is you don't have to do a whole lot. You just have to tell System Manager it is now the official security authority, and you have to do some work in order to implement those certificates all over the place. If you don't want to use System Manager, let's say that you have a reason that you want to centralize all of your certificates from your organization, which is a good thing to do. You're just a really good chance that your organization already has their own certificate authority already in place. For example, Active Directory. If you have an Active Directory server somewhere in your organization, that is a certificate authority. Larger organizations tend to have their own separate certificate authority server as well. So if you work for a company like Microsoft or like Avaya, they tend to have their own certificate authorities already centralized, already in place, run by a security team that is essentially pushing out the trusted certs all over the place, and they already have a process in place to sign certificates requests when you get those. So we've talked a lot about a trust so far, and the other thing to implement, or the other thing we need to worry about with certificates is encryption. Certificates natively are meant to set up one-way encryption and decryption. So essentially, your server is going to present a certificate as a part of that communication, and a part of that certificate is what's known as a public key. And a public key is a thing that a server can use to encrypt data, or I should say, a client. The public key essentially is used to encrypt data. The other half of the key pair that exists out there is known as a private key. As you probably guessed it, that private key is used to decrypt the conversation. So a public key encrypts it, a private key decrypts it. A private key is not a part of the certificate or the PEM. It is stored securely in a different location on the server. In a PEM style of certificate, the private key and the public key, they don't exist together. However, there are other certificate styles such as DER and P12 where you can actually bundle those together and have them as in one shot. So essentially the way a conversation actually happens is an encryption key set is essentially like an algebra equation. So the public key, which you get from your certificate, times your message, or essentially mangled together with this algorithm, gives you an encrypted message. The private key divided by this encrypted message equals your message. So in order to get a message back, you have to have that private key. In order to create the encrypted message, you need to have that public key. So how do you create a certificate? The process generally involves creating a public certificate and a private certificate on your server. You take that public certificate and have it signed by a certificate authority. You install that certificate authority's root certificates and probably the intermediate certificates into a trust store on your server. And then you install that public cert that you have signed by your security authority onto your server. So essentially you have a few things in play here. You've got that public certificate, you've got a private key or a private certificate, you have a cert that is signed by your root, by your certificate authority, and then you have all these trust things that are on there as well. So the two ways to create a server or identity certificate. One is to use a third-party application such as OpenSSL. I'll show that in just a little bit here, to create both the public and private keys. Another option that you have is to use the application's what they call the CSR or certificate signing request process. Now the CSR process involves the application creating both a public and private key for you. Now the nice thing is it is going to go and stash that private key. Remember that thing that can do all the decryption. And it stores it in a secure location, and you don't have to worry about dealing with that private key at all. It'll then allow you to download that public cert, and so you can have it signed by your certificate authority to make it valid and all that type of stuff. Now the CSR process will keep that private key on the server in that secure location. The nice thing is you don't have to deal with that private key, you only have to deal with the public side. So you don't have to worry about, oh my gosh, I downloaded this file, it's sitting on my desktop or whatever, and oh my gosh, somebody broke into my desktop or whatever, or somebody possibly stole this this public cert. The public cert is again public. It's the thing you really don't care about if they have. It is only used to encrypt data. It won't allow you to decrypt anything. The nice thing is the process of creating a certificate signing request is pretty much the same for every application that you're going to be dealing with. Communication Manager, ISO in the Windows world, IX messaging, AACC, AAS. Generally, this process is you're going to import the root certificates of the server that you want to sign your certificate, that from the service that you want to have sign those certificates. You log into server and you find the Create CSR section. In Communication Manager, this is in the SMI, AACC, there's an actual application for it. Every application does it slightly different how you do it, but the process is generally the same. You should be able to look up the basic documentation for your for whatever product that you're trying to deal this with, and look up CSR, and they should have a step-by-step direction of how to get to it. That CSR process is going to download, it's going to give you this CSR file. It may just be displayed on the screen. And that's the case, you just paste it to a text file. It might be a .txt file, might be a .csr, might be a .cer file. It actually doesn't matter. If you actually open it up, it's just like that blob of text I showed you earlier, except it's going to say begin certificate signing request and end certificate signing request, but the blob of text is almost the same. Then you're going to go to your certificate authority and have them sign it. Then you're going to go and re-import that signed file. So in Communication Manager, again, if you log into the, just go to the web page of Communication Manager. On the left-hand side in that menu, you're going to see under Security, Trusted Certificates. And then when you go in here, you're going to see a way to import the certificate from your authority. This over here, this picture on the right-hand side is actually from AES, exact same thing. You're going to import your trusted certificates. You'll notice over here on the left-hand side, there's also certificate signing request. Again, when you click on that particular option, it's going to give you a form to fill out and to sign that request. So when you actually click on that certificate signing request, you'll be asked a series of questions. Pretty much these list of questions are going to be the same for every application you're using, whether it's Internet Explorer, or not Internet Explorer, but IIS on Windows, whether it's an Avaya product, even Cisco products are the exact same thing. The questions they ask are exactly the same. You're going to be asked a common name or a CN. That's the host name of the server that's asking for that request. So generally for my Communication Manager, it's going to be the host name of my Communication Manager. They may ask for a SAN or subject alternate name. Not all applications are going to ask you for this particular thing. This allows you to list additional domain names, IP addresses, whatever you want to be listed in that certificate. Now, some applications are very, very picky as far as do they validate if I request to connect to www.avaya.com. If the certificate comes back and says salman1.avaya.com, if that doesn't match, the browser may say, hey, this is something weird. I'm getting a certificate from somebody else other than who I requested. In the voice over IP world, it's the exact same way. Well, what happens if you have multiple host names on one machine? Well, this is where that subject alternate name actually comes into play. You can list those additional ones. So my recommendation, particularly if you're dealing with Avaya stuff, is you can include your IP addresses, because chances are connecting to IP addresses, not domain names for everything. However, you may, some security companies and certificate authorities don't allow you to include IP addresses. They say it's a security risk if you do those. So that just depends on who you're having signed your certificate. You may be asked if this is a CA cert or if it's a self-signed cert. Generally, this is only used if you don't have a certificate authority or system manager to sign the cert for you. Generally, you're going to be saying no for that. You're probably going to be asked for the key size. If I would have given this presentation probably 18 months ago, 1024 is the number that everybody used. That's 1024 bits. 2048 is the new recommendation, but pretty much anything less than 1024 and less won't work anymore. There's no penalty to have a smaller key size, or there's no penalty to have a larger key size, I should say, with modern computers. Essentially what happens is for every bit of data that is encrypted across this link, it goes through an algorithm that is 1024 or 2048 bits long. So the longer a key string that you have, the more secure it is, but it also means it requires slightly more CPU power in order to encrypt that conversation. Again, 2048 is the number that everybody's using today for these conversations. A question came in over here, do you use wildcards and SANs as part of the IP address? And the cert would cover them all. Generally, a SAN is going to be an IP address, a very specific IP address, or a list of IP addresses, or it's going to be a particular host name. Host names can have wildcards in them. IP addresses generally cannot, from what I've seen. So the actual certificate signing request, again, communication manager here on the left-hand side. It's going to ask for a country name, state or province name, locality, organization name, organizational unit. Common name, again, is going to be the host name of that particular thing there. The hashing algorithm, again, doesn't matter as much for the type of stuff that we're talking about here. The key size, again, 2048 in this case here. And is this a CA cert in this case, or is it a self-signed cert? In our case, we said no. If I were to do this exact same process on Windows, this is the forms that I'd be using. Again, common name, organizational unit, city, locality, state, country. Again, this is the process that pretty much any application we're using is going to be asking these same questions. To get the signed certificate back into your server and match with that private key, you're going to have to either import that cert that was signed by your certificate authority as an identity certificate, service certificate, or sometimes they give you an option to complete the CSR. For most Avaya products, you're going to be just importing that final certificate, and it's going to know to match things up. There's a question about, are there any issues with using wildcard certs in regards to an Avaya system? I actually have not tried wildcard certificates on Avaya stuff, so I don't know if they work or not. But the process as far as getting the certificate back into your system, you're gonna have to look at your docs on that. Everyone treats that just slightly different, but generally you're gonna be just importing that certificate, and because the serial number matched what originally you created, that should pretty much match, and it should pretty much work. So the question of how does the private key get to this client for traffic decryption? So the private key doesn't actually get transmitted to the client itself. There is another temporary certificate that is actually created in the background based on the certificates that are presented. So, and that is a temporary private key that's done in flight based on times and things like that. So your private key is not actually ever given out. Okay, so I do have to have a warning here. So I mentioned, the process, it's really simple. All you do is you go create your CSR, you get it signed and you import it, and boom. The problem you're gonna run into though is most applications, in fact, every application is only going to allow you to have one certificate be valid per application at a time. So the second you go and import that final CSR into your server, chances are that server is now going to be using that new certificate. If you haven't already created trust with all the applications that are talking to your server, things are going to break. Communication is going to fail. So before you activate any identity certificate or service certificate you've gotten back from your certificate authority, you'll need to add the root and intermediate certificates into every device that needs to talk to it first. So again, the process is going to be, you're going to download those trusted certs. You can go to your certificate authority. If you're going to System Manager, I'm going to show you in a second here how to get to that particular trusted cert, that root cert. You're going to install that trusted cert on every server that talks to what you're trying to secure. So chances are you're going to be running around and touching every single server to import this root cert. This is a time process. Now, the nice thing is it's usually not service affecting, and I'll always say usually because I will never say always, but it's usually not service affecting to import trusted certs into any application. I've done this on communication managers, system managers, session managers, voicemail systems, AES, AACC, CMS. I've imported trust certs into all these devices and phones themselves, and it's never been service affecting. Now the application, adding certificates into phones, you do have to reboot the phone, and usually in order to pick up the new configuration file that points to those, so that may be service affecting, but generally you're going to be pretty safe just doing that as a first round. You then generate that CSR on the server. You're going to take that CSR file, you're going to have it signed by your certificate authority. I'm not going to really talk about the process for third-party certificates. If you're using, for example, let's say GoDaddy, you log into your account on GoDaddy, you buy a certificate, they're going to essentially give you a entry fee or whatever to sign a certificate. You then upload your CSR to them, and then they're going to email you back that signed certificate. So when you have that signed certificate, you then install that certificate on your server. And then eventually, after you've gone through and done all the signed certificates on all your servers throughout your entire organization, you then remove your old certs that you're no longer using. In the case of Avaya equipment, they have those wonderful things called demo certs that you're probably going to want to remove. Otherwise, you just don't want those floating out there anymore. So there's a question as far as can you put multiple host names in the SAN and have one cert cover multiple systems? The answer to that is yes, you can, as long as that server supports multiple SAN entries. Again, it depends on the particular server. Now, the reason why you may not want to do that is because you then have to transport that private key across multiple machines. And the process of moving private keys around on Avaya equipment can be pretty difficult. In fact, in some systems, you actually have to have root access to do it. So it's not straightforward. A lot of times it's just going to be easier, just plop down the money. If you're getting a third-party cert or if you're using System Manager, it's free to do. Just use individual server certs for each one. So getting that root cert, if you're using a third-party CA, you'll usually have that information posted on their website. Again, if you go to like Namecheap or GoDaddy or VeriSign or whatever, they actually have a list of all the certificates that you can get. Sometimes when you go and order your certificate, they're going to go send you an email with a link to all those certificates in 15 different formats, in a variety of different ways, with everything chained and all that type of stuff. You're just going to have to figure out which one you're going to want to use. Always go, again, when you're dealing with Avaya stuff, you're always going to want to use PEM format, PEM, and that will get you pretty far. A lot of times they're going to say they're going to have a chained PEM file or they're going to have intermediate ones. Always choose to have the individual certificates. That tends to work better for all the different systems. So using System Manager as a certificate authority, again, System Manager has a built-in certificate authority functionality. The nice thing is System Manager aware applications like Session Manager, Breeze, all those automatically get certs created and assigned to them when you're doing that the DRS process, the synchronization process. System Manager uses a tool called EBGA or EJBCA to sign in, to create and sign those certificates. Now, unfortunately, Avaya has kind of just bolted on this EJBCA tool, so it looks really weird when you're trying to do it, but I'm going to show a couple of screenshots here how you actually do that process. If you've never used the CA functionality in System Manager before, you will need to have it create a new certificate authority. There is a link to some documentation over here on the Avaya website to creating a new certificate authority in System Manager. When you do this process, it is possible that certain communications can break. You need to just watch out and read the documentation very clearly when you go through that create CA process. I would not do it in the middle of the day. However, when I have done it before, it didn't break things. That being said. So to actually, so you've gone to your product, you've created this CSR file, and you want to have it signed by System Manager. What you're going to do is you're going to log into System Manager, go to the Services, Security, Certificates, and then Authority. So you're going to be dropping through the menus to get to this particular section. And when you do, you're going to be into that EJBCA application. Along the left-hand side, there's going to be an option under RA functions called Add End Entity. Again, these menu items and all stuff do not speak English. Even somebody who understands security stuff, it's kind of a pain in the butt. But what we're going to be doing is we're actually going to be creating a login that we can use to sign a certificate. So when you click on that, you're going to get this wonderful form here on the right-hand side that looks very similar to that CSR form. All we're doing is we're creating a login and a password, and we're telling System Manager, these are the things, like this is essentially a database for System Manager so it can keep track of the different certs. These are optional fields. The username and a password, so the username over here and the password are required, so you're gonna have to do username, password, and then confirm password. And then you do wanna do that common name. So again, the common name is gonna be that host name that you're gonna be using. The rest of the fields you can absolutely leave blank. Along the bottom, you wanna make sure that your certificate profile is ID client server, and then your CA is the one that you've used. So now that we've gone and created a login to create our, to sign our certificate, we're gonna go and to the public web section of the EJBCA. So from here, we're gonna go create certificate from CSR, and you're gonna get a form that's gonna ask for a login and password. That login and password is the same one that we used in this form over here. It's then going to ask you to upload the CSR or paste it in. If you have that CSR file in Notepad or whatever, you can just paste it right in. So the form's going to look like this right here. Again, that username and password. So username and then enrollment code is going to be the password, and you can then upload that .csr file, or you can paste it in over here. You want to make sure that result type is going to be a PEM certificate only. Once you hit OK on there, it's going to go and give you a download of that final certificate that then you're going to be able to import into your application. The other thing you're going to want to make sure that you grab is that root certificate. You get that by going into that public web section again, fetch CA certificate, and then when you click on that, it's going to allow you to download the certificate, that primary certificate, that root certificate, as a PEM file. Again, it's going to be over here. When you click on that, you're going to get a .cer file that then you can import into, again, any application, whether it's IAS, whether it's System Manager, Session Manager, really whoever needs to have access to that cert, you're going to have. Again, anything that is already connected to System Manager is already going to get a copy of that CA cert. So cruising right along here, I've got just a few more minutes of a presentation. So tools of the trade. I've mentioned quite a few times OpenSSL, but there's a few tools that that I use very regularly when dealing with any type of certificates. Most common one is going to be OpenSSL. OpenSSL is a free tool. I'll talk about it here in just a second. Additionally, check out sslshopper.com. They have an invaluable set of tools that SSL Decryptor I mentioned a little bit earlier to decode certs, convert certs. They also have a really good frequently asked questions section on how to use OpenSSL. So OpenSSL is an open source tool that can be used to create certs, manipulate certs, convert certs, or connect to a server to figure out what is my server actually presenting. It's a command line tool. It's available for Windows, Mac, and Linux. To grab it, you go to openssl.org, and you're going to have to kind of search around the site a little bit to get the actual, what they call binaries, or the thing that you can install on your computer. But if you go to https://wiki.openssl.org/index.php/binaries with capital B, you can actually download the file that has openssl.exe. or for the Mac or all the other versions. So if I want to see what my certificate, my server is currently presenting, I can do this tool, OpenSSL space s_client dash connect my server's IP address or host name or whatever I might have, :5061 minus show certs. So if I have just command prompt over here, I do OpenSSL s client connect, and then if I do sip.msu.edu :5061, and I can do show certs. This over here is actually going to make a TCP connection to my server, and it's going to pull back all the certs that my server is presenting. So I can actually go through and decode each of these certs over here. So if I go and pull this back, this right here, that was just one of them. Nope, I grabbed two. Let me just grab one. My mouse handling skills today have been not great. Okay, here we go. So through end certificate, if I go to that sslshopper.com again, let me go pull that up here. And if I paste that certificate in here, on the bottom here, it actually has decrypted. It says my common name, sip.msu.edu. I have subject alternate names in here for all my other servers that are using that same cert, organizational unit, and all other stuff right here. It tells me my issuer and all that type of stuff, and the dates that it's actually valid. Now, if I go back to, where is my command prompt? The nice thing is this tool also gives me that same certificate chain information, so it tells me my common name and all this other stuff right here in OpenSSL as well. I can connect to other servers. The neat thing that I use this tool in particular for when I'm trying to diagnose things, I can actually copy and paste this begin certificate to end certificate, put it into a text file, upload it to my server as a trusted cert. Now I won't have cert problems for that particular issue. So I don't care what I'm connecting to, I can actually pull down the certs without having to talk to anybody to figure out what do I need to actually trust that user. So again, this over here shows the depth, how many certs are needed to be trusted. So in this case here, there's 3 certs. So I had my primary cert, an intermediate cert, and then a root cert. In the chain, it shows S:, and then as a subject of that cert. So this over here is the subject. Again, we've got sip.msu.edu and the common name. The I is the issuer of the cert. So who actually issued this particular cert in my case here is from Ann Arbor Internet 2, Incommon RSA cert CA. And then again, I can copy and paste that into SSL Shopper to get more information. When you connect to a server using the S-client method, it should show every cert in a chain. If it only shows a single cert, you may not have uploaded those root or intermediate certs to the trust store. Some applications will also require that you upload them to the server or identity areas as well. Again, if you only have a particular, if you're only seeing one, chances are that's really bad. You need to have at least that root cert as well. You should also make sure that a server is showing the correct cert that you installed. I've seen some applications where you install that server, the server certificate, everything looks like it should be fine, but still showing an old cert. You actually have to reboot the server for it to start working. Again, this is just another way to diagnose those problems. You can also copy and paste the certs that are being presented, add them to trust stores. Kind of feels like cheating, but it's not. It's how you fix things. So Wireshark will also allow you to see the setup messages that happen within a TLS cert or TLS conversation. You can begin with when you see that certificate exchange information before an encrypted message occurs. You can also see some of the failures that happen as well. Like OpenSSL, you can actually extract the certificates and import them or decode them on SSL Shopper. So how do you do this? If you're using Wireshark, look for things that say like client hello or server hello, server certificate, server key exchange, all that type of stuff, and you'll actually see inside the, when you go to the secure sockets layer portion of a conversation, you'll actually see all the certificate information when you're going back and forth. Because of time here, I'm gonna go skip loading up Wireshark. I'm sure most of you have seen it at least once. And again, there's the Avaya trace tools. In the Avaya trace tools, trace SM, trace SBC, trace CE, all those. You have the ability to troubleshoot TLS issues for SIP packets as well. When you start your trace, you're going to select the TLS handshaking box. Now, when you click that TLS handshaking box, one thing to note is it will show every TLS connection going to your server. It is not, none of the filters are going to work. However, it will give you some information as far as what certificates are being presented when a conversation is happening, and also, more importantly, why something might be rejected. Chances are it's going to come back and say certificate not valid or not trusted or something along those lines. You'll definitely want to do this when your server is not that busy. I took these screenshots here last night at 11:30 p.m. and I still had like thousands of conversations happening back and forth. So for me to pick the one conversation I was trying to get to fail was pretty difficult. So keep that in mind when you're doing this. So by using the tools, you should be able to figure out if a cert is at least being rejected because of a trust issue. 90% of all TLS issues you're going to be running into are because of those trust issues. The CA or the intermediate certs don't match, the host name or the CN doesn't match to the server that you're trying to connect to, or the SAN is not supported or is incorrect. The rest of the stuff is going to be much harder to track down. Things like cipher mismatch issues, TLS version mismatches, and all that type of stuff. Now, when you're using Wireshark or using Trace SM or Trace SBC or any of those tools, it will give you some hints as far as the cipher version mismatch or the TLS version mismatch. TLS version, the quick way to try if you suspect that it's a TLS version, drop down to TLS version 1.0 and then creep back up to the version that your security team wants you to use. And that usually is how you can fix those, or at least identify that that is an issue. Other than that, issues could also be general networking issues. Troubleshoot like you would any other TCP issue. Am I dropping packets? Do I have packet loss? Are packets being routed the wrong way? All those types of things when you're dealing with this. So that is the end of the conversation. I have about 5 minutes remaining, and I'm going to go through here. Some of the questions here. William said that you could filter out by IP address to get one conversation filter with the I option. So the I option actually does not work when you're using Trace SM because the filter actually happens on the display side and not the capture side. Now, if you are doing the Trace SBC tool, you can actually set up a pre-filter using the command line, and you can filter out some of those TLS issues on that case. But the general rule is you're going to be seeing everything that hits your server. What about certificates for IP phones? So on an IP phone, you're generally not generating a certificate, you're just going to be implementing the trust certificates. So how you are to do that, and this is a question from Roberto, essentially in your 46xx settings file, you're going to point to your trusted certs. So that's going to be your root cert, your intermediate certs, and any server certs that you may have on your session border controller or any other devices that you're connecting to. Once you have those in place, you're also going to have to copy and paste those into text files and upload them to your web server. And essentially your phone is going to go download those files and then trust those, and then it should be able to make connections. My goodness, there's a lot of questions here. I have an issue with certificates on the Avaya Aura environment. All remote workers are working fine. Via video H175s tell me I have an issue with certificates. What process do you use to generate certificate for first-time installation? Fortunately, I don't have the 3 or 4 hours required to go through that entire process. System manager, you're kind of follow the documentation I just provided here to get you started, but you're going to have to look at the system manager documentation to generate certificates. Is there a penalty or drawback if the CN on an Avaya server identity certificate does not match the native host name of the server itself as seen in Etsy hosts? You will probably run into issues if your server is doing what they call validating host names. So that is an option that you can turn off, and between session manager and session manager and communication manager, that is turned off by default because they use just random host names all over the place. Now, when you're dealing with adjuncts, voicemails, call center applications, you're probably going to want to turn that option off because it is kind of a pain. When you're using System Manager as the CA, how does one decrypt SIP and RTP for troubleshooting purposes? Where do you get the keys to decrypt the data? This is from William. So You can't actually get copies of those when you're using your server to generate those certificates using CSR files. So the issue is you probably won't be able to get access to those private certs in order to decrypt traffic using Wireshark. If you use the Trace SM, Trace SBC, Trace CE tools, those will decrypt the traffic and allow you to see what's going in there. So you're going to be more reliant on using those tools to figure out what is going on. Unfortunately, when you're dealing with Avaya equipment, getting access to those private keys is very difficult, particularly because customers very rarely have root. Our biggest challenge has been getting cert that will work on Mac OS when using Equinox. How can I speak to that? The biggest thing you're going to want to deal with if you're dealing with, so my suggestion when dealing with Equinox or remote workers or iOS users, Android users, and all that type of stuff, on your external interface of your session border controller, you're going to want to have a trusted, you're going to want to get a third-party cert, a trusted cert by like Google, or sorry, by like GoDaddy or Namecheap or Network Solutions or Amazon or any of those types of companies. Have them get you, have them sign your cert because those are going to be already trusted by the operating systems and everything else. So you won't have to deal with any trust issues with any of those. If you absolutely can't use a third-party CA to sign your certs for application deployments like Equinox and all that type of stuff, you're going to have to work with your IT team to manually push out those certs to those operating systems, and that can be painful. You're going to have to use an MDM tool. You're going to have to use Active Directory to push those out, and unfortunately, it becomes a long, drawn-out process. I believe there's quite a few questions still coming in here. I'm going to see if I can run through these. Our time is almost up here in just a minute. If voice traffic is traversing an encrypted VLAN, is TLS required? So that is a loaded question. Is it required? Not really. If you're dealing with SIP, you're going to have to use TLS. The reason why you're going to have to use TLS is Avaya locks down PPM, button data, stateful data, all that type of stuff to phones and to adjuncts. To TLS. If you're using unencrypted SIP traffic, Avaya does not allow PPM to work. What that means is you will have the basic SIPing 19 features. It will work, but if you want that button data and all the other stuff, you're kind of hosed. If you're dealing strictly with H323 digital phones, analog phones, you're not dealing with SIP, you technically don't have to deal anything with encryption. I still highly recommend it, but it is not required. If you're doing with SIP, it pretty much is required at this point. Question, is it better to use System Manager or Active Directory as your CA for your Avaya products? I personally like using System Manager because it's one of those things that is in my control. And the nice thing is that it is already inherently trusted by the session managers, Breeze servers, or anything else that talks to System Manager. So you don't have to worry about doing more signing and all that type of stuff. Now, there are advantages of using Active Directory. In particular, you can have somebody else deal with the security side of it when they're dealing with all that type of stuff. But yeah. Can I install third-party root CAs as well as System Manager CA certs? That's a question. Yes, you can. It's a long question here. When using a System Manager as a CA, how does one decrypt SIP? We already talked about that. Does AD FD download trust certs when defined in the 46XX settings file, or does it need to be installed on the desktop and client? So the Avaya Aura FD, agent desktop for, yes. So if you're using Avaya Aura agent desktop, it will use the 46XX settings file. If you're using Equinox, it will use it as well. However, for Avaya Equinox or now IX Workspace or Workplace, you do need to have the operating system trusted as well. It's kind of a weird thing in order to download files and all that. How do hard phone certs differ from soft phones, particularly with AADF? Pretty much that's, I've kind of mentioned that already. You're going to want to make sure you have those certs in the file. And there's still a few questions here. I think there's one more here that I can get. For new ADS server deployments, the CSR file should be created on the ADS side and then signed by system manager, and both new signed. Okay, so I think we've got most of the questions here. I greatly appreciate your time and spending your lunch hour or breakfast if you're in California with me for this presentation. Again, I do appreciate honest feedback on how I've done on this. I know we kind of ran through a very complicated presentation here in just over an hour. So thank you very much. And Paige, it's back to you.
Thanks, Nick. I will send you the Q&A report as well so you can answer questions, and I can send that out to all attendees as well. Thank you to Nick for speaking to us today. Please be sure to fill out that survey as you exit the webcast and let us know what you thought of today's session and what you would like to see going forward throughout the year in 2020. Be sure to check out our upcoming webinars at iaug.org/learn. Thank you and have a great rest of your day.